So as the number of particles, that's moles, increases, so does volume. And vice versa. Pretty straightforward there. Yes. Oh, I thought you were. Matt, I have. All right, so again, this is just getting redundant at this point. He says over N. So N is moles. Have we come across using N for moles yet? I can't remember.
Yeah.
We have?
I think so.
I can't remember if we have.
And then like the fancy M was molarity.
Fancy M was molarity, yeah. So a lowercase n, okay, as in nickel, okay, is the unit for moles. And we're going to come across that a lot in this chapter. Of course, this is called U. And that's going to be equal to some constant. Maybe we call this constant this time A. The constant really is not the big deal. The fact is that since there is a constant, we can relate befores and afters to each other. So, for a confined gas, V1 over N1 equals A equals V2 over N2. So again, moral of the story is we can throw out A and relate initial conditions to final conditions. What do you think has to be true of volume units? Been true all the way along so far. They just have to agree. And then we could just say N equals moles. Now, just to be clear, with moles, we could talk about micromoles or millimoles, okay, but they're still moles, right? Moles is moles. Doesn't matter if you got a prefix for it. We'll do a quick example, which is probably at this point so redundant we don't even need to, but we'll do it. Okay, so let's say we have a 10-liter balloon. So this is an example. A 10-liter balloon contains 14 grams. Contains 14 grams of N2. If 5 grams of N2 are added to the balloon, then what is the total volume? Or what is the new volume? All right, so first of all, when you look at this, okay, I see volume, and at this point it could be talking about Boyle's law, V and T. It could be talking about Charles' law, V and T, or it could be talking about Avogadro's law, V and N. And then I look further, And I don't see anything but masses. But if I give you masses, masses are as good as giving you what? Moles, all right? So basically I've got moles. So first I have volume 1. Volume 1 equals 10 liters. And I have an N1 in the form of 14 grams of N2. Now, off to the side here, N2 times 14 is 28 grams per mole. So this is 1 mole over 28 grams, or 0.5 moles of N2. So I've got half a mole in there to begin with. Volume 2 is what I'm looking for now, but I know it's got to come out in liters because it's got to agree. Now the thing to be careful of is this. How many grams are in the balloon at the end? 19. Because you're adding it, all right? So just make sure you're thinking about what's going on. You've got the 10 plus the 14, so you have 19 grams divided by 28 grams per mole. Actually, I should say N2. N2 times 1 mole, 28 grams. And then 0.68 moles. So I can solve my equation, V1 over N1 equals V2 over N2. Now again, I'm starting you out easy here, where the things that you've been solving for are in the numerator. Okay, so we're solving for volume 2. Now again, if you were solving for one of the N's, probably N2, you could do a lot of multiplying, like multiply it, get it over here, and then multiply by N1 over V1 to get that over here. What I would do is an easier trick is if I wanted N2, I would take the whole thing and flip it over and start there. Because if I say 1/2 equals 1/2, can I flip that over and say 2 over 1 equals 2 over 1? Yeah. So I can take an equation like this and just flip it. And then that would put N2 in the top, and then isolating it's a lot easier. Everybody follow where I'm going? Okay. But for now, all we're trying to do is find V2. So we multiply both sides by N2. And I get V2 equals N2 V1 over N1. I get V2 equals N2 0.68 moles times V1 10 liters divided by N1 0.50 moles or 0.5 moles. V2 equals, so the volume should go up. I'm adding stuff to this balloon. I get 13.6 liters. All right, last thing I got for you. We're not going to go through the whole thing here. This one's not in your book. Here's just one more relationship that sums it all up. And it's called Gay-Lussac. Gay-Lussac. Okay, at least you're smart. Okay, so it's Gay-Lussac, I believe. Probably you'd ask Mr. Bayer, and he'd probably say it, I would imagine, something like that. Probably with much more flair, right? Just saying. He's the man, by the way. He says, temperature and pressure are, well, think about your tire pressure sensor monitor. Why did it go off in fall?
Because it's getting hotter.
No, it's getting colder, so the pressure in your tires is going down. And in the summertime, you don't want to have your tires overinflated and drive through the desert because the pressure will go up, right? And then you can burst the tire. So what kind of relationship then? Direct. Are directly related. And so I could go through and say and vice versa and all that stuff, but I'll just say this. P1 over T1 equals P2 over P2. Pressure units, guess what has to be true? Must agree. What about temperature? Must be Kelvin.
How is that any different from Charles's law?
Charles was talking about volume and temperature. Okay, now I thought about doing homework. I put it up there. You know what? I think I'm gonna say forget that. And the reason I'm gonna say forget that is because tomorrow you have